सभी को मैसेज नहीं ना किया
जैसे
थे।
मान लीजिए मेरा आवाज नहीं सुना दे या पीपीटी देखने में दिक्कत हो, तो काइंडली फोन करके हमको इंटीमेट कर दीजिएगा, ये या टाइप करके।
तो
रिकॉर्डिंग
बोला गया था कि सभी को पार्टिकुलर ईमेल आईडी से मैसेज किया जाएगा, लेकिन कहाँ हमको नहीं भेजा गया था, हम दूसरे से ले लिए थे।
लेट अस स्टार्ट टुडेस क्लास। पीपीटी कहाँ है? हाँ, oh, so I am very much
आवाज आ रहा है?
interested to share this lecture today. That is design of steel structure. This design of steel structure is mainly useful for the third year and final year students. You might have already studied this subject, those who are in final year. So, in this design of steel structure, in today's class, I will deliver you the mainly the introduction part and thereafter the design part. So first you see regarding the introduction, you go through one by one. Steel structures is a metal structure that is made of structural steel components or members connect with each other by welding, riveting or bolting. These are the connection method to carry loads and provide full rigidity. Because of the high strength of steel, these structures are reliable and require less material than other types of structures. Steel can be used for various purposes as a structural material in trusses, beams, high-rise buildings, long-span bridges, industrial structures, airports, transmission towers, overhead tanks, chimneys, bunker and silo, and so many structures, important structures. Nowadays, steel is the most commonly used structural material due to its various properties like great strength, good ductility, and high strength, and other properties also. So you must know about the what are the advantages of steel as a structural material and why you are interesting to use this structural steel, design of structural steel. The first advantage is high strength per unit weight. This is purely ductile material, lightweight, long life. You provide the proper maintenance, easy to addition and alteration in structures. Construction erection is fast, higher scrap value, and recycled materials. And the disadvantages of steel structure. Steel as a structural material is highly corrosive and need fireproof treatment are required and fatigue drawbacks. It is very poor in fatigue. Now, in the design of steel structure, the main topic we will deliver, we will share that first of all you have to know the material. What are the properties of steel material, and what are the design? How to design? Then the most important part of any steel structure is the connection. Without connection, your structure will get failed. If you have to provide the proper connection, then only your structure will be having more rigidity. And so mainly we are providing the voltage connection and welded connection. Other connections are also there. So we'll discuss it later on. Then eccentric connections, design of tension member, design of compression members, design of lacing and batten systems, design of column-based foundation, design of laterally supported beams, and design of laterally unsupported beams. These are the two different parts. Laterally supported beams and laterally unsupported beams. We will come later on this part. And then important subject topic is the design of plate girder and design of gantry girder, design of roof trusses and industrial building. And plastic analysis also you may have to design. So you see, you listen me please. The course deals with design of steel structure using limit state design method. So why we need limit state design method? What is difference between limit state design and other design? So actually, in 2011, in the year 2011, during attack in World Trade Center in America, USA, so we need to use the limit state method in India. Earlier, we have designed this steel structure by the working stress method. The early before this code, limit state design of steel structure, IS 800 2007, we have the same code, limit state working IS 800 1984, and that was by using the working stress method. So we have modified our code and we have released this in 2007. That is called IS 800 2007, the latest Indian standard code of practice for general construction. So we have to use we have to use this code IS 800 2007 for the design of steel structure. And also you have to use the IS standard book number 1, that is properties of structural steel rolled sections. The properties of structural steel rolled section means you are using the different rolled section for the construction of steel structure. Then you are using the combination of other rolled structure to construct the steel structures. So these are the connected by the different connections. And what are the properties of different rolled sections? That is given in this handbook. So what will the unit weight, what is the length and diameter, what is the depth, what is the thickness, and what is the other properties like least radius of gyration in x direction, y direction, and so many properties. All properties you will get from this handbook for the particular districts section. And this section, rolled sections are given as per Indian Standard Code. So you cannot deviate this section as per other beyond this Indian Standard Code. So you must use this IS handbook number 1, properties of steel rolled section, for using the different steel sections. Then after you have to use the IS 875 1987 part 1 to part 4 code of practice for design load for building and structures. The part 1 is for the dead load, part 2 is for the live load, part 3 is for the wind load, and part 4 is the you are having the wind load. So, and also you can use this IS 1893 2002 code for seismic forces. So these are the used for the design of steel structure. So now, if you talk about this limit state design method, so you must know what is the limit state design and what is the working stress method. Limit state method means limit state method considers more critical limit state of strength and serviceability. The acceptance limit for the safety and serviceability requirements before failure occurs is called a limit state. A structure should be designed to withstand safety all loads likely to act on it. And working stress method, so actually we are not using that method presently, but you must know that what is the working stress method. We had used this in earlier previous code. Working stress method is an elastic method of design. The working stresses should never exceed the permissible stress, that is ratio of yield stress to factor of safety. Now, if you are using the factor of safety in working stress method, and what is partial safety of factor that is used in the limit state method. So you see here, what is partial safety factor? This is the most important part. A partial safety factor relates to limit state design, and this method of design is commonly used in modern structural engineering design. In limit state design, partial safety factors are applied to the loads and material strength to obtain a safe design. So you have to use both partial safety factor for the loads and for the material strength. That both are used for the limit state design of steel structure. And factor of safety we had discussed in working stress method. A factor of safety relates to permissible stress design. A factor of safety, however, is the load carrying capacity of an element divided by the load of an element. The factor by which the yield stress of the material of a member is divided to arrive at the permissible stress in the material. This method of structural engineering design is now superseded by the limit state design. So now we are not using anywhere in the working stress method, we are not using the factor of safety. Always we are using the partial safety factor and limit state method. Remember it. So if you design any design of civil engineering part, the main aim of design is to overall stability, capacity or strength against collapse, fire resistance, serviceability, durability, economy. These are the factors we are considering for the proper design of a steel structure or proper design of any structure. So after that, we have to see if you are using the Indian standard IS 800 2007. So our handbook number 1 for properties of steel rolled sections. So what are the rolled section? These are the rolled section. You will see this. You look at this figure. Types of section that carry shear strength or load, that is T bar, L angle. This is tube, hollow tube, square hollow tube. This is wide flange I section. This is I beam. This is channel section. Actually, this roll section is manufactured in manufacturing companies like Tata Steel, Jindal Steel, and they are manufacturing this as per the Indian Standard Code method. So Indian Standard Code method, suppose if you have this I section, I beam, what is the flange width, what is the web depth, what is the total depth, what are the thickness of web, what is the thickness of flange, and this is specified in particular I section and as per Indian code. So you can never change this section or change the dimension of this member. You have to use this as per Indian Standard Code, and this is manufactured by the bigger companies. So this is called the rolled steel shapes, and sections. Now, we will talk about the built-up section also. The combination of these two road sections or more, the combination of two or more road section is called built-up section. Suppose if you are have to construct a gantry girder, so this I section is not sufficient. You have to provide a channel section over the top of the I section, or for a heavy structure like a multi-story high-rise building, you have to join the two or three road section. So if you are joining like a lacing member, you are providing the two channel section back to back, or you are providing a I section over the cover plate with the cover plate. So this is the built up section. So always remember this: what is the rolled steel section and what is the built up section. Now you can see what are the commonly available rolled section, I section, T section, channel section, angle section, steel bar, tubes, plates, sheets, and strips. And there are two type of words generally used for the plates and plates. Plates and flats. Flats means having the width lesser than 400 mm. So that is called plates, and this is sometimes it is plates. So how to denote the Indian standard section? We are suppose now we are considering the example of a beam section. Beam matlab I section means I section. Beam section rolls steel I section. Indian standard junior beam. Indian how to do pronounce these words? If you have to design a section Indian standard junior beam, then you have to denote it ISJB. So Indian standard light beam, ISLB. Indian standard medium beam, Indian standard wide flange beam, Indian standard heavy beam. This is for the I section. Similarly, for the different section, channel section, angle section, like angle section, unequal angle section, equal angle section having the two legs, one in horizontal, one in vertical. So, if both legs are equal, then it is called equal angles. If one angles are not equal, it is called unequal angles. Now you have, for example, rolled steel section, I section, ISMB 500 at the rate of 0.852 kilonewton per meter. What it means? So if you will have to design a steel structure section, in the design problem you will be given ISMB 500 at the rate of 0.852 kilonewton per meter. Means this is the total depth of the section. This 500 depth of the I section, and the unit weight also given 0.852 kilonewton per meter. Weight per unit length. This is the total depth. ISMB 500 means the total depth of the section is 500 mm, and unit weight per unit length is given. Similarly, for the different section, T section, channel section, angle section, and other sections, we are having the dimension of the section, and then it also given. This section you have to refer in the handbook number 1 to know the properties of particular section. In these properties, you will get the moment of inertia, what is the other dimension, thickness of wave, thickness of flange, width of flange, radius of gyration, everything by using the handbook. So always you have to refer the IS 800 2007 and handbook to know the properties of particular round section. So after knowing these parts, come to the connection. So I think you must understand, you have to understand very well about the material, and you are as a third year or final year students, you are knowing the properties of steel. What are the density, what are the ductility, and what is the ductility of mild steel, what is the ductility of steel, and what is the stress strain diagram. So everything you are already studied, and you are very familiar for that. Now I have to start the. I'm supposed to understand that you are very much well known. You are very well known for that material of the steel, and either you refer any book and go through that. Now, after completing this introduction, have to go for the connection. See, a connection is generally defined as the location where two or more elements meet, or a joint is a region where two or more members meet. A joint is a region where two or more members meet. So, what are the method of connections? Generally, we are having a riveted connection, bolted connection, welded connection, and pinned connection. So, um, much attention should be given to design of connections. Otherwise, the structure will be poor in spite of the most efficient design and members. So what I mean to say that if you are using the very high member to construct a structure, steel structure, and your connection is poor, then there is no meaning for the good connection, good structure. So this all the steel structure all depends upon the design of connections. What are the connections you are providing? Riveted connection, bolted connection, welded connection, or pinned connection. You have to design these connections, and then your structure will be having the good strength, load carrying capacity, and rigidity, serviceability, all. So among these four connections, you must know about that. Riveted connection is absolute nowadays. Riveted connection is absolute nowadays due to number of drawbacks like high noise during construction, less efficient, require high maintenance. So many drawbacks are there with the riveted connection. And at present, we are not at all using the riveted connection anywhere, particularly for the limited state design. So, what are the design connections we are using now? Mainly bolted connections and welded connections are used for steel structures. Although riveted construction is absolute, we are not going to design, but an simple idea but an understanding of its behavior and design is essential for the strength evaluation and evaluation of a structure. So suppose some students will going to join railway or some any other organizations, and they are assigned to go for retrofitting of rehabilitation of old bridge. This bridge is constructed with the riveted connection. So without knowing the idea about the riveted connection, how you will go for the repair? So you must have the some idea about the riveted connection. But mainly you have to go for the design for steel structure by bolted connection and welded connection. Next, So you might have seen so many structures like this. This figure shows the riveted connection. Means what is that? Riveted connection means in this joint of this channel section and this gusset plate, we are having to make holes as per the diameter of rivet. We are making the holes and we are inserting the rivet over that. In the rivet, one person with the head and other person is to be take held by pressing it by machine or by hand. So, you see, this riveting is a method of joining together pieces of metal by inserting ductile metal pins called rivets into holes of pieces to be connected and forming a head at the end of the rivet to prevent each metal piece from coming out. Earlier method. So by working stress method, in old structure, we had already used the riveted connections for the design of steel structures. So I already told you this method is absolute now. So at present, as per ISA 2007, we are using the bolted connection. The design of bolted connection is generally done, followed by ISA 2007, where different types of failure of bolt connection is considered and designed accordingly. So you know all of we know the what is bolt and what is nut. So this is the nut, this is the thread, this is the head of the bolt, this is grip length, this is washer, this is shank, this is called shank, this is this is the length of the bolt, and this is nut. Again, you are having the length of the thread. So you must know all the things for the as a bolt. Bolted connection are mainly used nowadays for the steel structure. So bolt has different parts like head, nut, side, thread length, grip length, and nominal length, which will be required for our design. When we will be going for design of different type of bolts, we will see that these parameters are required. So for the designing of bolted connection, you must know the diameter of the bolt, shank diameter, thread length, grip length, nominal length, other parts. So we will be these different dimension like what is the nominal diameter of bolt, what is the gross diameter of diameter of bolt, what is the type of head, whether it is hexagonal or square. Like this we will come across. So you see this is the beam and column connections, and this is joined by the bolted connection. So it is very much clear from this figure what is the bolted connection and what is the riveted connection. So bolted connection is joined by the this figure shows very typical structure joint. This is the column and beam joint, and having the bolted connection. Now, if you talk this about the bolted connection, there are three types of bolts: unfinished or black bolts, finished or turned bolts, high strength friction grip bolts. And these unfinished black bolts are used for the unimportant structures. Means very usually you are using the unfinished bolt and thereafter we are having the finished and turn boards. Both are same, but having the finished boards having the some uh, the manufacturing high quality of manufacturing, and this head is having a hexagonal or square, and the grip thread and grip is made very sharp, and high strength friction grip is the boards which have providing the connections with the friction strength. So when we will talk these unfinished boards and finished boards, this totally load is taken by the bolts and plate. But this high strength and friction grip is carried by load carrying capacity is given partially by the friction grip. So this figure shows black ordinary bolt and nut, black bolt, the type 1, that is unfinished bolt. So this is the heads, shank, thread, nut and washer. Now finished or turned bolt. Second one, turn bolts are obtained by turning hexagonal shank to circular shape. The bolt hole diameter is only 1.5 mm larger than that of shank in case of turned bolt, and these bolts are used in special jobs like connecting machine parts subjected to dynamic loading. So what I told earlier, that unfinished bolts are used, unfinished or black bolts are used for ordinary structures, ordinary connections, and this is finished or turned bolts are used for the important structures, for the dynamic loading also, for connecting machine parts subjected to dynamic loading, and this having the hole diameter only 1.5 mm larger than the shank, but in unfinished bolt this is 2 mm larger than the shank. You can provide much bigger than this. Now you come to high strength friction grip bolts. Special techniques are used for tightening the nuts to introduce a specified initial tension in the bolt, called the proof load, which causes sufficient friction between the flying faces. Such bolts are called high strength friction grip bolt (HSFG). Due to this friction, the slip in the joint is eliminated. Joints with high strength friction grip bolts are called non-slip connections or friction type connections. Now, so among these all three bolts, the, the high strength friction grip bolt is having more strength, and this is used for the important connections. So, what are the advantages of these high strength friction grip bolts? High strength friction grip bolts do not allow any slip between the element connected, especially in closed tolerance holes. Thus, they provide rigid connections. Because of the clamping action, load is transmitted by friction only, and the bolts are not subjected to shear and bearing. Due to the smaller number of bolts, the gusset plate sizes are reduced. So, what is the gusset plate? Gusset plate is this plate provided to join two members. Suppose in a truss joint, you might have seen this truss joint. There are a number of tension and compression member meeting at a joint, and these are the T section, angle section, and channel section. So we are providing a gusset plate to join all the members at a particular joint. So this is the called gusset plate to provide the facility to join different member at particular point. And by using this high strength friction grip board, deformation is minimized. Here, holes larger than usual can be provided to easy erection and take care of lack of fit. However, note that the type of hole will govern the strength of the connection. Noiseless fabrication, since the bolts are tightened with wrenches. So, what I told, due to this noise, only we have absolute the riveted connection. Notes there will be very much noise in the riveted connection, and nowadays it is absolute. So, if you talk about these boards, um, what are the grade classification of board? These grades are generally used for the unfinished boards and finished boards. The grade classification of board is indicative of the strength of material of board. The two grade of board commonly used as 4.6 and 8.8. If you are given in a particular problem to use M20 4.6 grade bolt. What is M20? M20 is nominal diameter of the bolt. The diameter of bolts are generally provided 16 mm, 20 mm, 18 mm, 22 mm, 24 mm, and accordingly it is denoted by M, M20, M22, M24 like that. And also you have to provide the grade of bolt. 4.0, so many grades are there. So these commonly used grades are 4.6, 5.6, 8.8 like that. So if you talk about this 4.6 grade, so what it mean by 4 and what it mean by 6? Here 4 indicate that the ultimate tensile strength of the bolt. So tensile strength of the bolt 4 into 100, 400 Newton per mm square, and generally you are using 410 or 400, any one. There is no difference. In some book they are using 400, some books 410. And 0.6 indicate the yield strength of the bolt. Yield strength means 0.6 times ultimate strength. So if you are multiplying by 0.6 into 400, 240 Newton per mm square. Yield strength 240 and ultimate strength 400 Newton per mm square. So this is called 4.6 grade of bolts. So after knowing all the properties of bolt connections, so you have to go for the design of connections. So there is some definition terms used for the connection, either a riveted connection or bolted connection. So I am showing you, this is an example, pitch, staggered, hold and gauge. Staggered means zigzag, not in a single line or single. If you are providing this row one and then one here, then one there, then this is zigzag staggered pitch. So generally we are taking this as an example to know the different definition of pitch gauge. E. What is a small e? E here shows the edge distance, end of the plate to the center line of the rivet bolt. that is edge distance. G is the gauge. Gauge means the vertical difference between the two bolts are perpendicular to the applied load. The distance of the two bolts perpendicular to the direction of the applied load is called gauge, and distance between the two bolts parallel to the applied loads is called pitch. So you must know the what is pitch, what is gauge, what is edge distance, and end distance also there. E dash. It is not shown in this figure, and uh, this is given in this IS 800 2007. What is the minimum and maximum length of the pitch, minimum and maximum length of the gauge, end distance, edge distance, a staggered pitch for a staggered pitch for the chain pitch or chain staggered holes or chain holes. A minimum spacing of 2.5 times the nominal diameter of the fastener is specified in the code to ensure that there is a sufficient space to tighten the bolts. Fasteners are nothing but different type of connections, bolts, rivets. A minimum spacing of 2.5 times the nominal diameter of the fastener. Always remember, minimum spacing 2.5 times the diameter of the fastener as per the code. To prevent overlapping of the washers and to provide adequate resistance to tear out of the bolt. So what is why 2.5 times? To prevent overlapping of the washers and to provide adequate resistance to tear of the bolts. In respect of terminology or definitions, you can have some definition. Each of the bolts, it is a center to center spacing of the bolts in a row measure along the direction of the load, and the gauge distance is the distance between the two consecutive bolts of a adjacent row and is measured at right angles to the direction of load. Edge distance is the distance of bolt hole from the adjacent edge of the plate. Now, bolt dia pitch edge distance as per IS 800 2007. See here, nominal diameter of bolt 12, 14, 16, 18, 20, 22, 24, 27, 30 and above 36. And accordingly, you have to provide the diameter of hole to insert the bolt. For a lesser diameter, you have to one more size of hole 12, 13, 14, 15, 16, 18, 18, 20, 20, 22, 22, 24, 24, 26, like this. If it is above 36, bolt diameter plus 3 mm. So this you have to remember, and this will be used for the design of bolted connection. And then minimum edge distance for sheared or rough edge 22, 26, 31, 34, and 1.7 times hole diameter minimum edge distance. And for it steel rolled, sawn or planed, this is 1.5 times the hole diameter. Edge distance in this table, which are for standard holes, must be increased if oversized or slotted holes are used. Maximum edge distance 12 times epsilon, where epsilon equal to 250 by Fy 0.5 under root. Pitch 2.5 into nominal diameter of bolt. pitch maximum to 32 times or 3 mm, whichever is less. Maximum is distance, pitch minimum and pitch maximum. And if you are using the pitch in tension member, then you have to use 16 times T or 200 mm, whichever is less. And in compression, 12 T or 200 mm, whichever is less. What is T? T is the thickness of the thinner outside plate or angle. So minimum, if you are joining the two sections, so the minimum thickness of the member is to be considered as a T. And tracking fastener 32T or 300 mm, whichever is less, 16T or 200 mm, whichever is less for plates exposed to weather. So I think I have covered the basic part of the introduction of the design of steel structure, and you go through some refer some books, standard books to know the properties of steel. From the design of steel structure, you refer the IS 800 2007. I knowing that most of the students are not referring this code properly, IS 800 2007, or they are not understanding it step by step. So I suggest them to go through the design of a steel structure by the limited state method by IS 800 2007. They must understand the handbook number 1, for properties of the structural steel members, rolled section. How to know the different properties in the tabular form for the rolled steel section, and equal section, unequal section, built-up section, I section, T section, other section, channel section. You must know the basic things about the steel structure, otherwise uh, uh, I think you will be very much clear about the introduction part. So I will continue the this
Yes,
topics,
Alex.
this subject again in the uh, next class, coming class from tomorrow 4 to 5. So those who have attended the today's lecture, they are advised to remember all the things what I have given today, and you must know it. And you refer books and code. So otherwise, it will be useless for me and for you also to continue the subject. So whatever I today's completed, I suggest everyone to go through the uh, code handbook and any reference book, and complete all the part. If anyone having the queries, you take my WhatsApp number. You note down the my WhatsApp number, and you can ask me from giving by the WhatsApp. Please note down my WhatsApp number: 99736 80 156. Double nine. So I am typing in my number 1973680156. This is my WhatsApp number. You can ask any query if you have some doubt. कितना स्टूडेंट्स है? 28. हाँ संतोष जी, आप सुन रहे हैं क्या हमको?
यस सर।
हाँ, तो आज का क्लास यही कंक्लूड करते हैं, और जो क्वेरी होगा हमारा व्हाट्सएप नंबर दिया हुआ है, कोई स्टूडेंट है चाहे, तो उनको सजेस्ट कर दीजिएगा कि हमसे क्वेरी कर ले, और ये टुडेज का क्लास कंप्लीट करके आए वो लोग, तो फिर कल पढ़ाने में हमको इजी रहेगा या कंटिन्यू करने में हमको इजी रहेगा।
यस सर।
I'm concluding today's class. Thank you very much.
ओके, थैंक यू सर।
थैंक यू सर।
थैंक यू सर।
Okay.